guys, and welcome to HBN. Now in this video, in the playlist of limits, we are looking at what? Introduction to one-sided limit. We'll look at some examples and then how we apply one-sided limits as well. So please stay tuned even as we go into that. Now, one-sided limit simply describes the behavior of a function as it approaches a specific value from one side only. Let me give you a practical example. So let's say you have at a junction a traffic light. If you are to observe how the cars move right to left, especially at the junction, you'd see that there's a difference in their speed. So for the cars that are moving towards the traffic light, especially if it is red, they tend to slow down. So they have a particular behavior when they are moving towards it. But then when it's green and then they are moving away from it, their speed begins to increase. That is a basic idea of how one-sided limit is. So you can determine the limit from one side, that is from the left, and then the right-hand side. That is what gives us these two sides of the limit. So for a two-sided limit to exist, both one-sided limits must exist and be equal when we say the limit at a particular point exists. So first of all, both limits, that is the left-hand sided and then the right-hand, should all exist. The left-hand and then the right-hand limit should both exist for us to say what? That the limit exists. Now, if you can see what I have written here, this is the notation for one-sided limit. So if you have the limit of f of x, now this down here we say as x approaches a from the left. So from the left we put this negative there, but for the right we say the limit of f of x, that is your function, as x approaches a from the right. So these are the notations we need to take note of. Now let's look at some example. So we have this function f of x equals x squared over here, and we want the left-sided limit and then the right-sided limit. So there is a graph there that represents this. Let's take a look at that, come back here and then see how that looks like. So this is the function x squared, right? You put in the values of x and then getting their squares. And if you have to plot all, this is what you have. This here is the point we want the limit at. So talking of the right-sided limit, you are looking at the function, all these values, as you are getting to what? As you are getting to this point over here. So as you are getting to the point, you certainly come to a value of what? 4. That's tracing from this point to this point here. You see it is equal to 4. Yes. So that is if you are approaching 2 from the right hand side, it is actually going to give us a value of 4. The same way, let's approach 2 from the left hand side. So we are following along this path over here. You see. So if you follow along it and then we get to what? The 2, it will still give us the same value. For continuous functions, that is functions that are defined on every point, it is actually straightforward to determine that. Let's go back to the question and then apply what we have learned from the graph. So the left-sided limit was actually 4. You see, from the graph, we had that to be 4. This is the 4 over here. And also, the right-sided limit was also 4. Hence, we can say the limit at that point exists. If you take note, you realize that this one here has no positive or negative on top of the 2. That is the limit at the particular point. So when we say the left-sided limit and then the right-hand limit both exist, and it simply means the limit at that particular point also exists. Unlike this continuous function, which we'll be looking at in a bit, this here. So for this is what we have to consider. A piecewise function It says f of x is 1 for x that is less than 0. But then f of x is 2 for x that is greater than or equal to 0. Look at the graph of this over here. So for every x that is less than 0, these are all values of x that are less than 0. We are getting an answer of what? 1. It doesn't matter the value of x. So for negative 4, we'll still get 1. This is it over here. But for x that are greater than 0, that is from 1 onwards, we'll get a value of what? 2. That is what the function is saying. If you want us to look at the function again, this is what's over here. So for every value of x that is greater than 2, we are getting f of x being what? 2. Now, let's take a look at the function again. So as you can see, the left-sided limit over here, the left-hand limit is equal to 1, because as your x are approaching 0, you are getting 1. On the other hand of this same function, the right hand limit is equal to what? 2. You see, left-sided limit is equal to 1, right-sided is equal to 2. These two limits are not the same. So we say at x, the limit does not exist. It does not what? Exist, because the left hand limit and then the right hand limit are not the same. The limit at that particular point does not exist. That doesn't mean it doesn't have a left-sided limit. It actually has a limit as you are approaching it from the left-hand side, as you can see here. And it also has a limit as you are approaching it from the right-hand side. But at that particular point, which is x equals 0, we say the limit does not exist, because approaching it at the right-hand side is not the same as approaching it at the left-hand side. Alright, so this and many more will we be exploring when we start solving our question. And it's very essential that you understand these concepts so that when we look at them, you would be able to understand. Now, why do we even need to study one-sided limits? They help us analyze points of discontinuity in functions, just as we did in the previous ones. So it will tell you that the limit doesn't exist, hence there is discontinuity. It also helps us understand step functions and then piecewise functions. And very importantly, which we'll be looking at our last aspect in this playlist, it is very essential for derivatives and then integral. So basically, that is it for this video. See you in our next video where we start the algebra of limits. Thank you and stay blessed.